Okay, this is from exam June 2018, question 1B. So for this one, you need to determine dominant pair of roots, peak time and settling time of the uncompensated system by using value of gain K equal to 180. Please remember that dominant pair of roots must come from the closed loop transfer function. Okay, so for this one, plug in the value of gain K 120 from the closed loop transfer function. And to determine the dominant poles, you need dominant pair of roots. You need to determine the roots from denominator of the system. So based on this denominator, determine the roots. The complex conjugate roots are your dominant pair of roots. Okay, so choose the top left with the positive imaginary value as your dominant pole, label as O, because you will have the new dominant pair of roots in the next question. Based on this one, where this is equal to negative sigma d plus j omega d, then you can determine your settling time and peak time. Your settling time is based on this formula, and this is the peak time. And do not forget to write the unit for settling time and peak time with second. Okay. Next, we go to question 2. The given overshoot is 10% and also new settling time 2 seconds. So from the new settling time 2 seconds, you can determine your sigma d new. Okay, so this is your new sigma d. And from the 10% of overshoot, you can determine the zeta, the damping ratio, using this equation, using this formula. So be careful when using this formula. Make sure you know how to use your calculator. From this one, you have the value of damping ratio, and based on this formula, you can determine the theta and also theta d. I've already shared the diagram of theta and theta d based on this zeta, the damping ratio. Based on this formula, using the value of theta d, you can determine the new omega d, since you have new sigma d from the new settling time value. So based on this one, you can determine the new omega d, and then you can determine your new dominant pair of roots, which is based on negative sigma d plus j omega d. Okay. So once you have new dominant pole, back to the design. Now you can start your design. Determine pole of lead compensator. So for lead compensator, you have ZC. It's not really is not at origin and not close to origin, and you have a distant pole for lead compensator. So given ZC is negative 2.2, and this is from the original open loop transfer function. You have poles 0, negative 2 and negative 5, and you do not have 0. So plot all of these in this pole and 0 map. Pole negatives, pole 0, negative 2 and negative 5, and also plug in your ZC, negative 2.2, and then this is the estimation of PEC, the pole for the lead compensator, and also your DP new that you have just calculated. Okay, now what you have to do is determine all the angles. Okay, this theta one is actually equal to your theta that you have calculated from the value of damping ratio, because it is at origin. Okay, theta 2, this is the value of theta 2, 90. This is the value of theta 3 at this point. This is the value of theta 4. And the last one, using this formula, the summation of theta 0 minus the summation of theta pole is equal to 180. So from this one, theta 3 is your theta belongs to 0, only this one is positive. So theta 3 and the others belongs to pole, including theta for PC, which is unknown value of PC and unknown value of theta. Using this equation, you can determine the theta PC. So this is your theta PC 7.24. Using this equation, you can determine the value of PC. This one must use the theta PC. This one must use the value of omega D and sigma D from the new dominant pair of roots, not from the old dominant pair of roots. From this one, you determine the value of PC, 23.49. The next one, you can determine the transfer function for your lead compensator. You must include unknown gain for lead compensator and label as KC. So this is the given ZC in the question to -2.2, and this is the PC that you have calculated from the previous technique. The next one, based on the new dominant poles, so for the new operating conditions, setting time, peak time, and steady state error. You know that the new setting time is 2. And next, you can calculate your peak time based on the new dominant pair of roots using the omega D new. So this is the new peak time. And the next one is quite challenging. You need to determine your steady state error. Before you can determine the steady state error, okay, first you determine the compensated transfer function, meaning that it is the overall transfer function, the original open loop transfer function, this one, multiply with the lead compensator. So you multiply this one, both of this, you get this one. K is the unknown gain K from the original transfer function, this one. KC is the unknown gain for lead compensator. So you have two unknown gain K, K, C. Now, your job is to determine this unknown gain K, K, C. So based on this one, okay, you rearrange this equation for KKC, okay, you get this one. So the denominator on the top, the numerator at the bottom, you drag the KKC here to determine the KKC. Now your job is to replace S value with the value of new dominant pole, not old dominant pole. So S is equal to the new dominant pole, -2 plus J 2.729. Plug into this formula. Okay, you plug in the real and imaginary number, and then once you get the answer, you change or convert to magnitude and phase value. Okay, and take the magnitude value that is your gain KKC. So using this gain KKC, plug in back into this compensated transfer function. So this is the compensated transfer function after you calculated the unknown gain KKC, 296.45. Based on this one, determine your static error constant. Since this is type 1, meaning that you need to determine KV by replacing S with 0. So this is your KV. Okay, you calculate this one. This is your KV value. And then you determine the new steady state error as requested by the question. And this is your steady state error. This is the new steady state error, and then back to the original transfer function, uncompensated transfer function. You also need to calculate the steady state error using the gain given in question B1. So you have old steady state error value and you have new steady state error value. Then only you can discuss. Okay, you need to discuss based on these three parameters: setting time, peak time, and steady state error. Compare the old value and the new value. So this is how you discuss. TS is reduced to desired condition. However, TP and ESS has increased. Therefore, lead compensator need to redesign. That's it. That's enough. And that's all for question 1B and 1C for June 2018. Thank you very much.